Hello everyone. We started a series about building our first robotic hand prototype a month ago. And after I uploaded the video, I was in a research workshop and I couldn't able to make further videos. But in this video, we are going to continue our robotic hand prototype. We discussed how we are going to start from SolidWorks, our first fundamental design model. But before that, we have to understand how much SolidWorks do we need for this project. We are not going to learn every feature in SolidWorks. We are going to learn how much we need, and for that I made a plan that we are going to follow in this video. So without wasting our time, let's get started. So what is a SolidWorks? If I show you on the Google, it says SolidWorks is a brand of software used for solid modeling, CAD and CAE. It was one of the first 3D CAD applications designed to run on a desktop PC. The brand is owned by French software company Dassault System, but we are not interested in who own this, but we are interested in how we can model our 3D design. And the first part is learning the fundamental, sketching the fundamental. And as I told you, our goal will be to learn enough CAD to design our first robotic finger prototype. First of all, let me quickly start the software. It might take a bit time depending upon your laptop specs, and here you go, choose the part and it will start. So the first one is we are going to understand what is line, circle, arc, but we are not just going to randomly introduce line, circle, arc. We are going to make a circle because I believe with application we can learn easier, efficiently, faster. So let's make our first design, which will be circle. The goal is to make a circle of radius 5 millimeter. So I will go here. As you can see, we have different types of feature. We have this line, geometry, circle. When you click on the side button, you will see perimeter circle, but we are interested in making a circle. I will click here. And there are two ways of choosing plane. You can either choose from the menu side, or you can just click over here on the circle and it will shows up all the XYZ plane, and you can choose which plane you want to use. For this video, I'm interested in the front plane. I will click the front plane, and as you can see, a pencil icon appeared on my screen. This is the center. As you can see, when I touch the origin, it shows me a big orange dot. When I click here and just release my mouse, click once again, and your first circle is ready. Congratulations. But the line you see is blue. It means it is not defined. Now, what does it mean by defined? So, there are two types: underdefined, fully defined, and there is also another type which is overdefined. But we are interested in the underdefined and fully defined. Underdefined means the circle has more degree of freedom than it is required. Example, when I click here, I can just make it smaller or bigger, but I don't want that, right? So I need a constraint of 5 millimeter radius. I will just click over here, smart dimension, and click on the circumference of the circle, release the mouse, click and write 5. As you can see, millimeter. Hit yes. Now our circle is fully defined. You cannot click on the circumference and just release it because it doesn't allow. It has a constraint of 5 millimeter of diameter. Actually, I have to make this 10. Yes. Now it is the diameter of 10 and radius of 5 millimeter. The second thing you might notice, what if I want in another unit? And for that, we have an option on your right bottom. When you click over here, mmgs, we are currently millimeter gram second. But if you need IPS, inch pound second, CGS or MKS, you can choose either of the option. But in this video, we are more interested in mmgs. Congratulations, you just made your first fully defined 3D model. Well, technically it's a 2D model in SolidWorks. How do you know that? That's a good question, because at the bottom it shows fully defined. Now I can imagine a rectangle with two holes on the edges, the left edge and the right edge. Our rectangle will be of length 100 millimeter and breadth of 20 millimeter. So let me just quickly delete it. You can select the using Control A and hit delete on your keyboard. It will go. And I need to create a rectangle now. So we have different types of rectangular shape. Corner rectangle, center rectangle, 3D point corner rectangle, 3D point center rectangle, parallelogram. But we are interested in the rectangle. So I will just go same as before. I will click on the center and release my mouse. First of all, let me check this. Let me make it fully defined. And from this length, I will make it 100. 100 will be a lot. Let me quickly make it 50. And let's make our breadth of 20. Now the rectangle has the constraint applied on its length and breadth. It cannot move now. And as you can see, the sketch is fully defined as well. But I want to mix two circle here. And let's quickly make a circle. If I A, and you will see our figure has now become underdefined because the circle can move small, big. It can also be dragged on any position, but we don't need it. We need something that has constraint, that is fixed in the specific position, which means the left edge and the right edge. But we have to decide the parameter. First of all, let's go step by step. The first one will be the diameter. How much diameter do I need? So I will click over here and I will say, hey, I need 5 mm of diameter. Let's click on this part too. 5. Okay, the diameter is same, but I cannot make it larger or smaller, though I can just simply drag the circle, but we don't need that. So now thinking time. Think about it. How we can make it constrained so that it will not move either up, down, left, right. I'll give you 3 seconds. Correct. I will need constraint from the center to the breadth, from the center to the length. It means I need constraint from both x and y direction. Let's make it. I need from this breadth to the center of 10 millimeter of distance. I will click on this center of circle line, drag it down and distance. Let's make it 10. Same here as well. Center, release the mouse, click on the line and make it 10. Okay, so we have one constraint applied, but we still can move it up and down. We cannot move it on the side, we cannot alter with the diameter, but we can move it up and down. We don't need that. So we need a constraint applied on the x direction. So I will click on this point and I will click on the length and I will just click over here and say, hey, I need a 10 mm of distance. I will click over here as well on the center and the length. I will say, hey, I need a 10 mm of distance. Now, congratulations. If you see, the circle cannot be altered in x or y direction. It cannot be altered in diameter as well. And as you can see over here, it says fully defined. Now our figure has been fully defined. But there is still a problem. And it was one of my problem as well. Think like an engineer. Let's say if I alter with the breadth, this is 20. Now, if I alter it with 30, what is going to happen? The breadth will increase, correct? Let's make it 30. And our problem appear. What if I need the circle in the center at the same exact position? But since we have applied the distance from length to the center as 10, SolidWorks said, hey, I don't care what you mean. I just care about the constraint you applied. And SolidWorks is right. This is called design intent. Now, either I can just click over here and make it 15 and the same goes here as well. But what if I make it 40? I don't want to make it every time whenever I make any changes in the breadth. So we have a center line for that. We have a term called parametric modeling. It means no matter what you will changes, if you fix a part at the center, it will remain in the center. For that, one of the easiest way can be the center line. Let me show you how. First of all, I will click on the circle, hit delete. click on the circle, hit delete. Now let's first make the center line, and I will make the center line. As you can see, click over here and just drag it till the other side of the braid, click release, hit escape. Now let's do our process again, but first of all, let's make it 20. Let's click on the circle and just on this line. As you can see, when I'm touching the line, it turns into orange. Click on the line and just release the mouse. Click the line and release the mouse. What was our diameter? Was it 10? This time, let's make it 5. Click Smart Dimension. Click on the circumference. Make it 5. And now you know what we have to do. It can now be dragged in the X side, but we have to apply constraint now to not let it move. So you know now. Just go to Smart Dimension, click the center, click the length, and make it 10. Then same goes here as well. Click on the breadth and make it 10. Now, as you can see, we didn't apply the other constraint. We just applied, hey, I don't want to move it in the x direction, and we applied the 10 millimeter as the distance. We didn't have to add the dimension from the up and down or in y-axis constraint. That is because we already have the center line, and the center line says no matter what will be the breadth, just stay in the center. The center of the circle stays on the line of the center line, and now you can see it's fully defined as well. So this is called parametric modeling, and we are also playing around with design intent. So this is the first video on learning the basics of SolidWorks. We discuss about lines, circles, arcs, fully defined, underdefined, and what remain: coincident, parallel, perpendicular, tangent. We will discuss this topic as well in our next upcoming video as we design our robotic hand, but first with finger. I will also let you explore coincident, parallel, perpendicular, tangent, play around with SolidWorks. Just see whatever in your environment and try to model it with 2D. In the later video, we are going to discuss more about making our first finger, how to do assembly, and because we are going to learn the 3D